Hi guys, welcome to Basic Bit. Today is December 10th and we are on day number 10. The problem we're solving today is called valid mountain array. And so we're given an array and we want to return true if it satisfies the condition of a valid mountain array. So a mountain array has a single peak and all values up until the peak should be strictly increasing. And then all the values following the peak must be strictly decreasing. In order to check to see if an array is a mountain, first we can check to see if the array length is at least 3. And then we can make sure that there's a ascent and a descent. And the easiest way to check that is by taking the diff of every consecutive value in this array. So 0 to 2, 2, 1, 1, 1, and then we start the descent, -3, -1, -1. And so for any array that has a strictly increasing component immediately followed by a strictly decreasing component, that would be a valid array. In addition to this example of an invalid mountain array, other examples would be if the array was only strictly increasing, so something like this. It would only contain the ascent, but then no descent. Or something like this would also not be valid because it would only contain a descent and no ascent. The first thing that we should check is the length of the array. It needs to contain at least 3 values in order to be a valid mountain. So if length is less than 3, we can just return false. Next, we're going to use a function in the NumPy library called diff, which will give us the difference between consecutive values in an array. So we're going to have an array of diffs, np.diff of the array. In order to be a valid array, starting from the index 0 to some unknown index that will be the peak of the mountain, all the values need to be strictly increasing. So that means all the diffs have to be positive. And then followed by the ascent, there needs to be a descent from the peak to the last value in the array. And so every value needs to be strictly decreasing, and those diffs need to be negative. So first let's do the ascent. We're going to start at the first element, the first diff, and while I is less than length of diffs, we check to make sure that that diff is positive. And as long as it's positive, that means we're still on the ascent. So we can do I incremented by 1. At the end of this, I should be at the peak of the array. So if I is still at index 0, that means there was no ascent. And if I is equal to the total length of diffs, that means there's only an ascent in the array and no descent. So in those cases, we return false. And now we do the descent. We set j equal to I, and we loop through the diffs while making sure that the diffs, the value of the diffs at each j is less than 0. The descent needs to last until the end of the array. So if j ends up at the value after the last value in diffs, that means the descent lasted until the end of the array. We can run our code. Looks good, and submit. And it was accepted.